Get ready, because today we have an incredibly astonishing update from Lake Shasta. From a drastic drought to a nearly overflowing lake, Shasta Lake, California's vital reservoir, has consistently amazed its residents. Despite the escalating summer heat, Lake Shasta has maintained a level not witnessed in 2 years. By August 17, the water levels had reached 1,036 feet, a stark difference from those recorded in 2022 and 2021. However, a recent event has instilled fear in both scientists and water managers. What exactly happened? What factors contribute to Shasta's water levels? And what implications does this hold for Lake Shasta? Today, we'll find out. Don't miss it. The resurgence of the once dry Shasta Lake has brought a significant change to California residents' summers. Now, people in California can experience the benefits of a nearly full lake, providing a refreshing escape from the summer heat. However, despite this positive turn, scientists and water managers remain uncertain about the lake's future due to recent events. For context, Shasta Lake is situated in Shasta County in Northern California, spanning 31,000 acres and holding an impressive 4.5 million acre-feet of water. This makes it the third largest body of water in the state, trailing behind Lake Tahoe and the Salton Sea. The creation of Lake Shasta stands as a major achievement of the California Central Valley Project, CVP, a monumental initiative designed to manage the state's water resources for various needs. Among California's vast array of reservoirs, Lake Shasta proudly claims the distinction of being the largest man-made and most intricately engineered lake. Its construction dates back to 1944, when the Sacramento River was harnessed by the formidable Shasta Dam. This monumental effort occurred during a period marked by intense debates concerning the equitable distribution of California's most precious resource, water. Before the establishment of Lake Shasta, the Sacramento River flowed with wild abandon, its path unpredictable. This crucial waterway supported the budding agricultural sector that was gaining a foothold in the region, supplying the arid Central Valley with vital irrigation. Yet, the redirection of water into the northern reaches of the Sacramento Valley left the southern San Joaquin Valley grappling with insufficient runoff. This discrepancy ignited conflicts among different counties and municipalities, fueled further by the mercurial nature of the Sacramento River's flow. The river displayed stark contrasts in its behavior, running perilously low during the summer and autumn months. However, the situation would dramatically shift come spring, when heavy snowmelt from the Klamath Mountains and intense winter rainfall propelled the river's volume to new heights, often leading to catastrophic floods. To regulate these fluctuating conditions and optimize the river's potential, the U.S. Bureau of Reclamation spearheaded an ambitious initiative. In 1933, they embarked on constructing not only Lake Shasta but also 19 other dams along California's major rivers, including the Trinity, San Joaquin, and Sacramento. Shasta Dam stands as a marvel of engineering ingenuity, distinguishing itself by impounding not only the primary flow of the Sacramento River but also the McCloud and Pitt rivers. This convergence results in a collective annual inflow of 6.2 million acre-feet into Lake Shasta, an impressive feat that positions it as the 10th largest man-made lake in the United States. This significant role brings forth a considerable responsibility, as Lake Shasta has steadfastly met California's water demands for nearly a century. While agriculture remains a primary beneficiary of Lake Shasta, consuming approximately 60% of its annual discharge, the semi-arid Central Valley's municipalities claim over 30% of the yearly flow. The remaining water allocation is dedicated to fulfilling quotas set by the Bureau of Reclamation, aimed at rejuvenating riparian and wetland habitats that faced depletion due to the Sacramento River's flow alterations. However, the multifaceted contributions of Shasta Dam extend far beyond its imposing structure. Beneath its towering edifice, the industrious Shasta Power Plant hums with ceaseless activity, churning out an impressive 667,000 kilowatts of electricity, ample to illuminate more than 500,000 households. This annual surge of power infuses federal coffers with a substantial $50 million, thus elevating the dam's importance and amplifying its reverberations on the region's sustainability efforts. Meanwhile, the lake beckons with an array of recreational prospects, enticing enthusiasts to partake in boating, water skiing, fishing, swimming, and kayaking. The verdant environs of the neighboring town of Reading enhance the overall tourist experience, offering picturesque drives and convenient amenities. When the spring's high flows arrive, Shasta Lake springs into action, stowing away 1.3 million acre-feet of floodwater, a feat that diligently counters devastating runoff and erosional onslaughts. Yet, despite the lake's resilience, the unanticipated deluge this year outstripped even the venerable Shasta Dam's capacity, resulting in flooding incidents in nearby Reading and Shasta counties earlier in the year. Curiously, the ostensibly paradoxical notion of a high tide becomes a cause for jubilation among Californians, particularly as the state grapples with the intermittent repercussions of a two-decade-long drought. A pivotal juncture materialized in 2021, witnessing Shasta Dam plunge to its lowest watermark in 44 years. This towering 522-foot bastion reached a disquieting depth of 230 feet, marking its lowest level since 1977. A palpable ripple of concern swept across all stakeholders, not solely due to the looming threats to agriculture, energy, and clean drinking water, but also because of the impending jeopardy faced by vulnerable fish species such as the native salmon and trout. Don Bader, the area manager of the U.S. Bureau of Reclamation, underscores the compounding plight, emphasizing that the ongoing drought was exacerbated by the evolving demands since 1977. The region's lakes, once poised as reliable resources, grapple with the mounting pressures exerted by burgeoning populations and large-scale corporate farming ventures. Tasked with an onerous responsibility, the Bureau grappled with the formidable challenge of judiciously apportioning the lake's scant water resources. Striking a delicate balance between urban centers, farmlands, and the downstream wetlands, all of which rely on the lake's precious waters, necessitates intricate management. The repercussions were palpable, with drastic reductions in power provisions from the Shasta Power Plant to local communities, including Reading and its surrounding environs. The escalating urgency spurred the Bureau into action, compelling them to implement sweeping water supply cutbacks of up to 45% in some communities, a grim but necessary measure to salvage the diminishing reserves for the season's demands. However, in the year 2023, a remarkable transformation unfolded at Shasta Lake. Water levels, which had long been a cause for concern, began to rise, ushering in a newfound optimism. Although, a new development has occurred in recent times, and before the end of this video, you'll find out. With that said, this positive shift experienced in Shasta Lake could be attributed to a convergence of factors, each playing a crucial role in shaping the lake's fate. Now, the journey begins high amidst the Klamath Mountains of northwestern California, where the Sacramento River originates. Its annual journey is intricately tied to the whims of nature, dependent on both seasonal rainfall and the accumulation of snowpack throughout the winter months. The winter this year proved to be extraordinary, shattering records with snowfall levels reaching heights unseen in the past 77 years. This bounteous snowfall elevated the Klamath snowpack, boasting depths that surpassed the annual average by nearly double, with certain mountain areas accumulating up to 60 inches of snow. However, the stage for change was set not just in the mountains, but in the skies as well. Atmospheric rivers, dynamic conduits of moisture, surged forth, releasing an astonishing 30 trillion gallons of water onto the already saturated grounds of Lake Shasta. These atmospheric rivers, aptly described as rivers in the sky by the National Oceanic and Atmospheric Administration, NOAA, brought forth a combination of destructive downpours and intense rains that swept across the state, leaving a significant impact. Empowered by the evaporation of warm water vapor from the Pacific Ocean, these storm systems are capable of holding staggering amounts of water, rivaling the flow of the mighty Mississippi River. These atmospheric rivers can stretch over hundreds of miles, poised to unleash torrents of rainfall wherever they make landfall. With the advent of spring, a dichotomy unfolded. The storms acted as both a blessing and a curse for drought-stricken California. Despite the apparent contradiction, the state's dire need for water was no secret. The atmosphere seemed to respond to this need, delivering a deluge that held the potential to alleviate the dry spell. The impact of these events was felt most acutely in the Central Valley, where lakes such as Shasta and Trinity were mere shadows of their usual selves due to the prolonged drought. Atmospheric rivers, a significant source of precipitation, typically assisted in sustaining these reservoirs. However, the drought's persistence and the sudden influx of rainwater compromised the soil's capacity to absorb water, creating a heightened risk of flooding. As the warmth of summer spread its embrace, the snowpack atop the Klamath Mountains faced a rapid fate. The heat-induced downpours triggered swift runoff from the mountains, rapidly melting the snowpack that typically trickled down gradually during the spring and summer months. Shasta Lake, responding to the surges of runoff, swelled to near full capacity, an unforeseen transformation that had far-reaching consequences. The heightened water levels were not without their challenges. The rush of water and the lake's surging capacity led to hurricane-force winds and extensive power outages, plunging vast areas into darkness. The escalating situation necessitated mass evacuations, while the National Weather Service sounded alarms that any further precipitation would exacerbate the already precarious flood conditions. The result was astonishing: the atmospheric rivers, snowfall, and runoff combined to elevate Lake Shasta's water level by more than 100 feet between November 2022 and March 2023, reaching an impressive height of 1,040 feet above sea level. This resurgence confounded expectations, leaving water managers and local communities in awe. By May 6, 2023, the reservoir had risen further to 1,064 feet, a mere 3 feet shy of its full capacity. The implications of this resurgence rippled through the region, transforming landscapes and lives. The Charlie Creek Bridge, a testament to past droughts, now stood submerged, serving as a visible marker of the lake's triumphant rejuvenation. The Bureau of Reclamation also played a pivotal role in this transformation, meticulously managing water releases from Shasta Lake to maintain equilibrium, ensuring the benefit of various stakeholders. However, as of 7 p.m. on July 17, Shasta Lake's water level receded by 14 feet from its peak of 1,064 feet recorded in May and settled at 1,050 feet above sea level by August 17. While this might seem troubling, the dip can be attributed to the increasing summer temperatures, yet it's quite shocking to witness water levels maintaining an upward trajectory at this time of the year. Meanwhile, there's a lake transformation that hasn't been impressive and has caught the attention of water managers. We'll cover this soon. But before that, let's put Shasta's recent development into perspective. Consider August 17 of the previous year, when Shasta Lake's water level stood at a worrisome 934.31 feet, a substantial 133 feet below its full capacity. Even the same date 2 years ago, on August 17, 2021, saw Shasta Lake's water level at a concerning 911.36 feet. These figures stand in stark contrast to this year's water level of 1,050 feet. This resurgence of water levels has sparked optimism, igniting hopes for a year of prosperity. As Don Bader said in an interview with local reporters, when we allocate water, the first thing we do is meet our environmental needs. We allocate for agriculture per our contracts. We'll do the same thing again. What it's all based on is how much water supply we have in the lake. This year is looking a lot more encouraging than the previous years, so that's going to make the year a lot better for everybody, as long as we continue the rain. Meanwhile, the area manager of the U.S. Bureau of Reclamation, USBR, also stressed the significance of Trinity Lake, advocating for increased attention to its state. While both Lake Shasta and Trinity Lake stem from the same Klamath Mountain range, Trinity Lake lags 120 feet below its full capacity, despite its smaller size and shared origin. The question arises, why did Shasta Lake experience an influx of water far beyond its capacity, while nearby Trinity struggled to keep up? The answer lies in the imbalanced inflow from their respective tributaries. Lake Shasta benefits from a substantial drainage basin that draws from 3 distinct rivers. In contrast, Lake Trinity has a meager basin, reliant solely on the Trinity River for sustenance. This disparity leads to a slower replenishment rate for Trinity Lake, as mountain snowmelt gradually refills its basin. Lake Shasta, with an annual inflow averaging over 6 million acre-feet, contrasts with Lake Trinity's yearly intake of only 1.3 million acre-feet, the lowest among major Central Valley Project dams. Consequently, Trinity Lake requires 22 months to reach capacity, while Shasta Lake achieves the same feat in a mere 10 months. Trinity Lake's plight worsened due to 3 consecutive years of drought, the harshest among all California lakes. Its last satisfactory year, in which water levels reached historical averages, was 2019. The reservoir's storage capacity suffered due to the extended drought period, leading to a shallow beginning for the winter season. Recent data from the Department of Water Resources highlights Trinity Lake's challenges. By April 1 of this year, its capacity sat at just 51% of historical averages and 37% overall. Mary Lee Nix, the Bureau of Reclamation Region 10 Public Affairs Officer, noted the stark difference between Lake Shasta's reliance on rainfall and Trinity Lake's heavy dependence on snowpack. Trinity's slower pace of filling might be attributed to the relatively reduced rainfall in the northernmost part of California. Most atmospheric rivers affecting the state have concentrated in the Bay Area and Central Coast, sparing the Klamath Basin from their direct impact. Maps from the U.S. Drought Monitor depict the northern regions, encompassing counties like Siskiyou, Modoc, Lassen, and Trinity, as experiencing moderate drought conditions, with even interior parts of Northern California displaying abnormally dry patterns.